So the mathematical example for gravitational force, we're going to just hit the news, and the inspiration for Tesla's Crew Dragon just took off, so we'll use some of the data from that and find out what the gravitational force is between Earth and the Crew Dragon. So the mass of the Crew Dragon, with the folks in it and payload and everything, 12,055 kilograms, and its orbit will end up being 585 kilometers above the Earth's surface. And the question is, what's the gravitational force? There's a couple tricks here that you have to know. First, we are aiming for the information needed for this equation right here, which is Newton's law of gravitation. We have the force is equal to the gravitational constant times the two masses and divided by the radius squared. So first piece, let's talk about finding the radius. The radius given in the problem isn't really the radius from the distance from the center of the Earth to the center of the spacecraft. It's just the distance above the Earth. So you have to add in the radius of the Earth to get the radius that belongs in our equation. So once you do that, you end up with 7.15 times 10 to the 6 meters. We want it in meters, so you've got to do the conversion also. And then we need two masses. One of the masses is the mass of the spaceship, and the other is the mass of the Earth. And so it'll be given to you, or you can Google it real fast. And we also need the gravitational constant. And you're going to plug all of these into the equation. And when you do this, you're going to end up with something that looks like this, where we have the force due to gravity, and then we have gravitational constant, mass of the spaceship, mass of the Earth, all divided by the whole radius squared. And it's just the radius that's squared, so you have to be careful when you're working this using your calculator. And watch out for order of operations. And I'll just do it that way in order to just make sure that I don't end up squaring things wrong. And you end up with 9.4 times 10 to the 4th newtons. So that's the amount of force that the Earth is exerting on the spacecraft, and the spacecraft is exerting on Earth. So there's a force between those two masses equal to 9.4 times 10 to the 4th newtons. Couple quick things about doing the math with this. When you're using scientific notation on your calculator, use the EE button. Don't do times 10 to the caret with the exponent. Don't use that. Find the EE button and use it, and then square this carefully. Most often missed on these kind of questions is people forget to square that denominator. Alrighty, bye-bye.